video we're going to look at how we can measure and present the uncertainty in a single value. We're going to be considering a value with a random uncertainty associated to it. In order to measure the uncertainty in a single value, we need to make a number of measurements of our value. The more measurements, the better. However, if you're doing this in a teaching laboratory setting, then your time is going to be limited, which is going to limit the number of measurements you can take. So in order to work out what the single value is, you should take the measurement at least 3 times. The value for the measurement is then given as the mean or the average of the measurements that you've taken. In order to calculate the uncertainty, you can use the formula range divided by 2. So the range of the values is equal to the largest value minus the smallest value. And then to get this as an absolute uncertainty, we just divide by 2. Now some sources recommend dividing by n, where n is the number of measurements. However, the limit of this as n gets very large is that the limit goes to 0. And so this can significantly underestimate the uncertainty if we take a lot of measurements. And the rule with uncertainties is that it's always better to overestimate our uncertainties than underestimate them. So range over 2 is the best formula to use to calculate the uncertainty when you've taken a number of measurements of the same value. Now there's 2 ways that we can represent our uncertainty. The most common way, and the way that you should use at the end of the experiment, is the absolute uncertainty. So the absolute uncertainty is the one calculated using range over 2, and it has the same units as the value that you're measuring. Now when you're presenting the absolute uncertainty, it's important that you present it with the same number of decimal places as the value. It doesn't make much sense to present the uncertainty with a whole lot more decimal places than the value that you've actually measured, because you're then effectively claiming that you know the uncertainty more precisely than you know the value, which would be ridiculous. So present the absolute uncertainty with the same number of decimal places as you present the value. The other way to present an uncertainty is as a percentage uncertainty. So the percentage uncertainty is calculated by dividing the uncertainty, the absolute uncertainty, gotten by using the range divided by 2, divided by the value, which comes from the mean of the values that you've measured. So this gives you the percentage uncertainty. If you want to present it as an actual percentage, you then need to multiply it by 100. So the percentage uncertainty can be useful as a step along the way when you're combining different uncertainties. So we'll be looking at that in future videos. So if our value is represented by x, we can represent the absolute uncertainty as delta x, and the percentage uncertainty is then written as delta x divided by x. Let's have a look at an example now. Here I have a set of 1 kilogram masses from our laboratory. So what we're going to do now is work out, well, what is the actual mass of these 1 kilogram masses. So in order to do that, we're going to measure the mass of 5 of them using a set of scales here. We're then going to calculate the average value, which is the value of these actual masses, and then we'll be calculating the uncertainty in this value as well, so that we know how close to 1 kilogram these masses are. Okay, so let's measure the mass of these 5 masses. This first one is 1,007 grams. This second one is 999 grams. This third one is 1,007 grams. The fourth one is 987 grams. And the fifth one is 1,000 grams. So if we now work out the average of that, that is exactly 1,000 grams. The range divided by 2 is the largest, which was 1,007, minus the smallest, which is 987, divided by 2. So that's plus or minus 10 grams. And so the masses here have a mass of 1,000 plus or minus 10 grams.